Hello, good evening. I decided to share with you something on canopy structures. When you look at this, basically I know very soon some of you guys are going to begin designing petrol station. This canopy is used for fueling vehicles and the rest, so I just needed us to have a look at what could be our interest area, and then special attention required from all of us. One, canopy structures are subject to wind effect, both horizontal, vertical, sideways. So you have to be very, very careful, especially uplift effect. So, and it's it's worst with canopy with only two columns or columns which are centered like this. This is more or less, and this is unstable construction. You need to be very, very mindful in terms of the connectivity between the roof and the column, and then also on the roof and the column here, and then the one here on the base plate area, because wind uplift and then push plus the self weight and other things and the twist can easily cause problem at the bolt connection, so you have to be very, very careful. I tried to model this, and then my interest would be to look at how winds tend to sway this structure, so you can pay attention to. When you look at the deformation, the different loadings are here. I have the loads due to self-weight, and then I have load due to dead load. Normally we put 0.25. We don't have snow loading here. We also have for live load, also we adopt 0.25. And then wind, I've considered 30 meter per second, which we get about 0.6 kPa. Basically, so this wind, the retro wind is supplied, but remember, as the wind is getting out, there is also what they call the drag effect and the uplift. So uplift tend to push this structure upward, and so you have to be very, very in both directions, both the y and the x direction. It has got that effect. Even in this longer direction, you have the vortices, you have the galloping effect and all those things. So the dynamics effect on this very, very, very serious. So you need to take note of that. Temperature loading also, both minimum and maximum. Normally when you're dealing with steel building, you have to be mindful of temperature. Temperature loading very critical. So after applying all this loading and doing all the boundary condition, you can now view the deformation and see the implication. Basically, I think you can look at the one due to self weight. The one due to self weight. How does your structure respond to self weight? You can have a look at. So because you have on two support system, highly stressed zone, highly concentrated loads are actually around the cantilever component. If you look at the deformation effect, then you will see that this thing tend to flap up and down because of the weight. And then if you don't connect very well, then this cantilevering support can easily give way and the structure fails. This is something you need to take note of. If I look at the wind effect in the x direction, how does this structure respond? You can see that actually these two columns are overstressed, and then the next point is at the point, the connection between the truss and the column, and also between the column and the foundation, the staff column. So if the connection here is not done very well and properly rigid, this structure, there are 2 points where the structure can fail suddenly. The one at the roof and column connection, and then the one at the column, and then the staff column. That is the effect of the horizontal wind. in the shorter direction. What about the one in the longer direction? How does the structure respond? You can see the implication. This is how the structure responds in the lengthwise direction when wind is affecting or is moving or is going through. So this is one of the, it is not uplift. So I'm going to apply. What about the uplift effect? So the uplift effect, definitely, which now you as an engineer need to be careful, is this one. You can see it's trying to lift the whole canopy upward. So 2 points again you need to take note of. The two main connections, the one between the column and the truss system, and then the one between the column base and the stub column, which is the foundation. That is something you have to take note of. Very, very important. Of course, there are these smaller members that will be failing locally, but globally, that is what you need to do. And once the connection between the truss system and the column fails, then wind will lift the thing up, overturn it, and the result may be catastrophic. You need to take note. What about temperature effect, minimum temperature? How does temperature affect our structure? So when you look at the temperature effect, you will see that this is our minimum temperature. We applied about 15 degrees, and about 17, but at least on a level about 15. Now that is for minimum. What about the maximum temperature? How does it affect our structure? So that is how the temperature, maximum temperature and the minimum temperature affects our canopy. Then this. Now what about if we combine dead load, self-weight, and wind? How do they perform? In a situation where we don't have any live load on it, how will the structure perform? Supposing temperature is also negligible. So when you look at that in the x direction, look at combination of dead load, self-weight, and wind in the x direction. Definitely that's how the structure behaves. And when I take it to in the longer direction, how will our structure behave? That is how the structure behaves. Okay, you can see there, because this is now both the horizontal wind, the drag effect, and uplift. So this is now how vortices can be formed. Then before you know it, your roof is blown up, and the place around will be affected. Damages caused by this structure. Okay, what about the stresses? The stress distribution on your columns and pier, because our interest is to see interest area when you are supervising the project. Which area do you pay special attention? So you can have a look at this. So I can easily look at the beam, then I give this column, and I'm able to look at this, then should be able to look at the different loading. How will this structure perform if the wind is there? What happened? This is how our structure will be behaving. This will be how it behave. You can see the canopy beams having very high value and high mobile forces and shear forces, so you have to be a bit careful with that. And so this is exactly what this is the absolute load. Then this is the moment wind is in the shorter direction. This is how we look at. So all these areas need special attention for most of this canopy. So in brief, when you're doing design, you need to know, I told you, load path and the response of the structures. Very, very important. Once you understand critical areas, you should pay more attention. Once you do a model and you run the analysis, then you go to code of practices and some text and look at connection designs. The connections has got the balls, the barren material you're connecting, and the plates. So all the requirements are all there in the code of practices, or some softwares do help, like Robot Structure or Idea Statica can help you to do the modeling and designing this connection. So please let us pay attention when you get exposed to this kind of design. Take some time and avoid premature collapse of your structure. Thank you so much.